I invite Dmitry Kochergin, who will bring us up to speed on recent developments. In fact, I will split my talk into two parts. First, I will cover new features or functions that appeared in PHOTOMOD 6.5 version, and then I will focus on performance of different processes. So these are the new developments. In fact, the changes are essential, but they are more on the internal side. If we take the bundle adjustment, it has been rewritten, although outwardly it looks the same, or the distributed function. There are new tools of 3D vectorization, UAS, data processing. It's all about stepping up effectiveness. The new bundle adjustment algorithm has benefits that are best represented on these two images when there are great angles of flight. So this new algorithm is better suited to support such flight specifications. Plus, there is a self-calibration procedure that is now in place. New concept of distributed processing, again, increasing reliability and resistance to local network failures. I mean, these processes never die out completely. This is self-calibration tool, different types of cameras, different UASs. As for the DSMs, true ortho or 3D model improvements, you can read for yourself. Again, better accuracy, greater quality, 3D model layers and tiles. For fast displaying and for faster use. DSM DTM filter modifications have occurred. This is a 3D model from point cloud and 2.5D derived from DSM. Some changes have taken place for 3D models from satellite imagery. There is direct georeferencing for PhaseOne. So there is external orientation and internal orientation, all subject to data input in the camera. We will tell you more about vectorization in the course of the master class the day after tomorrow. New templates for roof vectorization, new types of snapping, and so on. Now, PHOTOMOD Conveyor. It should come out, be released any day now. There is a new user interface. Secondly, there are auto measurements of GCPs from georeferenced raster object. The time needed to create those is much faster now. You can load the points and optimize the project. Now let's move on to the second part, productivity estimation. So what hardware did we use for running tests? 2 computers that Racurs has in the server room. You can see the specs. 12 core with 96 and 48 gigabyte respectively. This wasn't very rewarding, I must say. It's not enough to say I have so many cores and I think it would take a certain time to process an image. I mean, there are other criteria that come into play. Angles, obliqueness, accuracy. Is it a drone or not drone? The image size or number of images. This is where we tried to do a full-scale processing. We built a DSM, point cloud. We used, obliqueness, by the way, is also decreasing. Anyway, total number of hours is 31. Plus aerial triangulation, digital terrain model, true ortho, point cloud, and 3D model, which we generated in an honest way from a DSM. Now we have a lot of smaller images, 2600 of those from UAS, SONY ILCE-6000. Again, 85 hours, ADSM 70 hours, point cloud. Where we have 3.5 billion points, it took 45 hours, and true ortho and negligible 3 hours. In total, 120 hours of processing time, or 5 days. Now let's take DMC II, 1,700 images, and this is the output statistic. 7 days for ADSM, 5 days for point cloud, over 20 billion points, and true ortho, approximately 3 days, giving a total of 16 days. This is satellite imagery of Pleiades, 28 images of Seoul, images captured at different times. We gathered what we could from different angles. This is block layout, and the processing time is reasonable, 18 hours for such a project. One of the solutions perhaps it sounds too extensive, but things can be sped up if you use not 2, but let's say 8 or 12 computers. If we used all of the server room's capabilities, the processing time would have been substantially decreased. Also, we need to use SSD storages and optimize, exclude, or speed up the local network. The next slide is critical. We heard a lot that it's important to look at the output. Questions were asked to Roscartography. What is your final product? People don't need dense model all the time, let alone point clouds or true ortho and so on and so forth. So it is the same project. And in case of all output products, we have 16 days. Let's say we build orthophoto with 1 to 2000 scale. The DSM is 1 meter. The correlation is in direct proportion. Four hours instead of 7 days. 2 hours to filter DSM, DTM. 20 hours to build a classic ortho. And 3 hours for mosaic. Total time 2 versus 16 days. We used 15 centimeter for our orthophoto, relying on rougher surface. And another thing which wasn't mentioned today a lot, manual job in some cases. For example, in classic ortho and contours. Some of these models are extremely dense, so it has to be done manually. So human interference is required. And it may have to do with some errors in the process of filtering that cuts off some of the objects hanging or protruding above instead of being transformed. Issues come up with some bridges or intersections, and this is where digitization manually comes into play. A question was asked to Hexagon representative. What's the ratio between manual and automatic? I wouldn't say it's 90% automatic. I lean toward 70%. It's really hard to tell. Well, let's say there is an open area, nothing you have to do, and then you have a city sprawling, and then again it's 50% of manual labor. Bridges, let alone the large scale, if it's 1 to 10,000, nothing to do, 1 to 2,000, you really have to work.
But at our production office, they say 50-70% would be automated, the rest would be manual. That's it, that's why I have question marks here, how the time can be increased, because to answer this question would be quite difficult. So far, we have question marks. While the model is rotating, just to look at it, we have time for one question for Dmitry. The rest will be asked during the Q&A. Who wants to ask the question?
Yes.
As I understand, after
area triangulation, then generate a dense DSM, and then filtering generate a DTM, then to DOM. In total, 1,700 DMC II need 2 days. My question is that from dense DSM to DTM, compared with existing solution, compute point directly to TIN to DTM, which way is better?
Я по-русски, да, буду говорить для перевода?
I will answer in Russian for the translation. This is an interesting thing in terms of when we build DSM. Even when we know that we will be using this DSM for orthophoto, it's better to build it in a more dense way with a smaller size of pixel Y for it to be better filtered. And then the above objects will be removed much better by the filter. Because for orthophoto, one could have built not one meter DSM, but make it even rougher 4 times, and then the speed would increase. But the compromise between good filtration and the pixel size for DSM is caused exactly by this. So I suggest it's better to build DSM, not dots or tins, but because filters work better with that. But this might be a more time-consuming process. So to tell you for sure what pixel size we need for DSM is too hard to tell, but I'm sure it will be much easier filtered with smaller pixel size.
Later. Okay. Большое спасибо, Dmitry.
Thank you very much, Dmitry, for a very interesting presentation. Questions will be asked at the end.